Good evening, student. In today's topic, what we are going to see is that what is data analytics, what is machine learning, what is deep learning, how it differs, what is labeled data, what is unlabeled data, what are the different types of data varieties are available. That's what we are going to see in today's class. What is data analytics? Examining the raw data to extract insights, identify patterns and support decision making. Data analytics involves analyzing the large amount of data to uncover trends and make informed decisions. It applies techniques like statistical analysis, machine learning and artificial intelligence to extract meaningful insights from complex data sets. In chemical engineering perspective, chemical engineers deals with vast amount of data from sensors, lab experiments and industrial processes. By analyzing this data, they can improve product quality and enhance safety and reduce cost. The types of data has been classified as descriptive analytics, diagnostic analytics, predictive analytics and prescriptive analytics. What they mean? So, the example for descriptive analytics, monitoring the temperature and pressure trends in a reactor over time. So, diagnostic analytics identify the reason for process deviation. Example, investigating why a batch of chemicals did not meet the quality standards. Predictive analytics talks about uses the past data to predict the future outcomes. Example, forecasting the equipment failure based on maintenance history. Prescriptive analytics suggests the best course of action. Example, AI models recommending optimal reaction condition for maximum yield. So, these four types of analytics are crucial for decision making in chemical engineering. Descriptive and diagnostic analytics help understand past data, while predictive and prescriptive analytics allow engineers to make proactive steps. So, I can give a realistic example over here. When you go for a doctor, the doctor diagnoses the disease. Based on that, he will give a prescription. So, diagnostic analytics identify the causes of process variation. Prescriptive provides actionable recommendation in order to overcome and obtain the optimized condition. Predictive analysis historical data to predict the future outcomes. Descriptive analysis summarizes the historical data to understand the past performance. So, hope you understood with this example. What is machine learning? Machine learning is a subset of artificial intelligence, enables computers to learn from data and make predictions. Machine learning automates decision making by recognizing pattern in data without explicit programming instead of following fixed rules. Machine learning models improve their accuracy over time as they process more data. So, there are again the two types of subdivision under machine learning. One is supervised learning, another one is unsupervised learning. The supervised learning learns from labeled data, input output pairs. Example, predicting polymer viscosity based on temperature and pressure. Unsupervised learning identifies the hidden pattern in unlabeled data. Example, clustering chemical compounds based on molecular properties. Supervised learning is useful when we have past data with known outcomes, while unsupervised learning is useful for discovering the unknown patterns. Hope you understand, student, about the differences between the supervised learning and unsupervised learning. So, what is labeled data? The labeled data includes input features with known output values. The example, a data set containing temperature, pressure and reaction time as input with the corresponding yield percentage as output. In supervised learning, labeled data is crucial because it helps the model learn the correct relationship between input and outputs. This allows the model to make accurate prediction for new data. Hope you understood, student. So, uses in machine learning, supervised learning, the common applications like classification, sorting data into categories, defect detection, regression, predicting continuous values, example, reaction efficiency, and the other examples are spam detection, emails labeled as spam or not spam, and medical diagnosis, symptoms labeled with the disease names. Labeled data helps in tasks like classification when we categorize the information, and regression where we predict numerical outcomes. This is widely used in industries including chemical engineering. What is unlabeled data now? Unlabeled data contains input features without known outputs. Example, sensor readings from a chemical plant without labels indicating normal or faulty conditions. Unlike labeled data, where we know the correct answers, unlabeled data requires machine learning models to find patterns on their own. This is useful in detecting unknown anomalies in industrial processes. Uses of unlabeled data. Hope you understood. So, what is the difference between labeled data and unlabeled data? That is a very important thing. Used in supervised learning requires human annotation. Unlabeled data used in unsupervised learning identifies hidden patterns. Labeled data is more structured and useful for specific tasks, whereas unlabeled data allows models to discover unknown insights. So, now we will move on to the topic of what is deep learning. Deep learning is a specialized branch of machine learning that uses artificial neural networks. Deep learning mimics the way the human brain processes information. It is highly effective for complex tasks like image recognition, speech processing, and advanced predictive modeling. How deep learning works? Deep learning models consist of artificial neurons arranged in layers. The input layer receives raw data. Hidden layers process data and extract patterns. Outlet layer produces final predictions. Deep learning models use multiple layers of artificial neurons to process data step by step. Each layer extracts features, improved accuracy over time. Now, what is the application of deep learning in chemical engineering perspective? Process optimization and fault detection, prediction, maintenance. So, when you talk about process optimization, adjusting reaction condition in real time to maximize the yield, and similarly for fault detection, using vibration data from pumps to predict failures before they happen. So, deep learning has transformed chemical engineering by improving efficiency, safety, and predictive maintenance. This model helps in optimizing the operation and preventing failures. So, students, hope you understood what has been taught today for you regarding what is data analytics, what is machine learning, what is labeled data, what is unlabeled data, what is deep learning, what is supervised learning, what is unsupervised learning. So, I urge you actually please go through this term very keenly with an example in chemical engineering perspective. With this note, I conclude this section. We will see in next section shortly.